when is ANOVA test preferred over t-test? To answer simply, if we have more than two groups, then we prefer ANOVA over t-test. However, the important point here to note is that technically we can perform t-test with more than two groups as well. However, doing a series of t-tests would increase the possibility of making type 1 error, creating the issue of compounding the type 1 error rate. And we can solve this kind of situation by running a single test, which is ANOVA. Now let's expand this concept in detail. Both ANOVA, that is analysis of variance, and t-test are used to determine whether there is a significant difference between the means of multiple groups. Now let's coming back to our main point here, that is ANOVA is preferred over t-test when there are more than two groups to compare, as conducting multiple pairwise t-test increases the likelihood of making a type 1 error. Now a type 1 error, also known as false positive, occurs when you reject a true null hypothesis, that is you conclude that there is a significant difference between the groups when there is not one. For example, let's say you decide to get tested for COVID-19 based on mild symptoms. There are two errors that could potentially occur. Type 1 error, that is false positive, is the situation where the test result says you have coronavirus but you actually don't. And type 2 error, that is false negative, is a situation where the test results say you do not have coronavirus but you actually do. Now, the probability of making type 1 error is denoted by the alpha level, which is set at 0.05. Normally, this means that there is a 5% chance that you might reject a true null hypothesis. Now, when comparing multiple groups using individual t-tests, the probability of making at least one type 1 error increases. This is because each t-test has its own alpha level and the probability of making a type 1 error accumulates across all the tests. Let's see an example to understand this particular situation. For example, let's say you have four groups A, B, C, D, and you want to compare their means. To do this using t-test, you would need to conduct 6 pairwise comparison. 6 because you need to compare AB, AC, AD, BC, BD, and CD. So with each t-test having a 5% chance of making a type 1 error, the probability of making at least one type 1 error across all the 6 tests is given by 1 minus alpha raised to the power the number of tests, which will give you 0.265 or 26.5%. Now, just to explain these mathematics here, it's a simple probability calculation because the term 1 minus alpha represents the probability of not making a type 1 error for each individual test. When this term is raised to the power of number of tests, that is 6 here, that will give you the probability of not making any type 1 errors across all the 6 tests, and subtracting this value from 1 gives the probability of making at least one type 1 error across all the 6 tests. In other words, it is a complement of the probability of not making any type 1 errors. So as you can see, the probability of making type 1 error has increased from 5% for a single t-test to 26.5% when conducting multiple t-tests, that is for all the 6 t-tests. So to control for these increased risk of type 1 error, we use ANOVA, which allows us to compare the means of multiple groups simultaneously while maintaining a single alpha level. So ANOVA does this by partitioning the total variance in the data into two sources, which is between group variance and within group variance. It then calculates an F statistic, which is the ratio of the between group variance and to the within group variance. If the F statistic is large enough and the corresponding p-value is less than the chosen alpha level, that is 0.05, we reject the null hypothesis and conclude that there is a significant difference between the group means. In summary, the ANOVA test is preferred over t-test when comparing the means of more than two groups because it maintains a single alpha level, controlling for the increased risk of making type 1 error when conducting multiple comparisons, and it also allows for simultaneous comparison of multiple groups, making it more efficient and easier to interpret than conducting multiple pairwise t-test. Now, another important point to remember here that if the ANOVA test detects a significant difference between the group means, you may still need to conduct a post-hoc test. For example, Tukey's HSD or Bonferroni or Dunet's to identify the specific pairs of groups that have significant different means. These post-hoc tests also include adjustments to control the type 1 error rate.